In this class we continue the solution of the transportation problem using the solver. So, we look at another example of a transportation problem. Once again there are 3 supply points and 3 demand points. The 3 supplies add to 40 plus 40, 80 plus 50, 130, while the 3 demands add up to 100. So, this is not a balanced transportation problem, this is unbalanced with total supply exceeding total demand. We also bring in another aspect into the problem and say that the demand number 2, which right now requires a minimum of this 30, is willing to take an extra 20 if given, and demand number 3 would like to take as much extra as possible. So, now the person with demand 1 is going to take exactly 30, the demand 2 let us assume knows that the total supply exceeds total demand by 30 units and says up to 20 extra I can take. So, this person can be given any quantity between 30 and 50, the minimum 30 should be given. So, this person can be given anything between 30 and 50, and this person can be given anything between 40 and 70, because this person has said that he or she would like to take as much extra as possible. So, now what happens, the maximum demand becomes 30 plus 50 plus 70, which actually exceeds the 130, and then we realize that the extra 20 and 30 that they are seeking, one of them or both may get less than what is maximum possible for them. It is also interesting that we would like to use up all these 130 items because they are willing to take extra. So, this formulation, all the 130 have to be used because we want to give as much extra as possible. So, the supply becomes equations. The demand here will be an equation because the minimum demand has to be met. Here it will be 2 inequalities, it is between 30 and 50. Here again it is 2 inequalities between 40 and 70. So, let us look at the spreadsheet formulation of this problem. So, let us look at this problem. So, the 3 availabilities, so once again there are 9 variables x11, x13 to x33. So, there are 9 variables which are here, which are written here. I have given some arbitrary values 0, 0, 40 and so on. The objective function coefficients are written here. The objective function value is written here. So, this is your Cij, Xij. So, this will become B5 into F3. So, B5 is here into F3 plus C5 into C5 into G3 plus D5 into H3. So, the objective function is a multiplication of this. So, 0 into 8 plus 0 into 9 plus 40 into 7 and so on. So, that is written here. Now, the 3 supply constraints are all equations because we want to give as much as we can. So, 40, 40 and 50, whatever goes out is equal to what is available here. So, all the supply quantities are exhausted. The first demand constraint is an equation. We said exactly 30 the first person will get. The second person will get a minimum of 30 which is shown here and a maximum of 50 which is shown here as a less than or equal to constraint, because you will get a maximum of 50, the minimum of 30 is shown as a greater than or equal to constraint. The third person will get a minimum of 40 which is shown as a greater than or equal to constraint and a maximum of 70 which is shown as a less than or equal to constraint. So, there are 3 supply constraints, there are 5 demand constraints, 1 for the first demand, 2 each for the second and third demand. So, there are 8 constraints here. So, the problem has 9 variables and 8 constraints. So, let us check what is the solution. So, we go to the solver and I have already defined all of them here. So, the objective function is given as B9, the decision variables go from B5 C5 D5 to B7, C7, D7 which is shown here, you will see that 1, 2, 3, 4, 5, 6, 7, 9 constraints have to be there. So let me just check that. So the 3 equations are B11 is equal to D11, B12 is equal to D12 and B13 is equal to D13. The first demand is an equation, so that is also here 14. So second one is a greater than or equal to inequality, B15 is greater than or equal to D15 which is here, B16 is greater than or equal to D16 which is here. So all the 8 constraints are here. So there are 8 constraints, 4, 5, 6, 7, 8 and you can see that there are 8 constraints are here. So I can solve the problem directly. So I solve it, I get this solution. So I get the same solution which is here, just to show that the solver is giving a different solution. So let me just add another 10 here. So we now realize that it is here and we also realize that it is actually infeasible because you are getting 50 greater than or this is okay, 50 less than equal to 50. Here you find that 50, 40 and 50. So the first one is violated. So at present the solution is infeasible, but nevertheless we will see what happens when we solve it. So I am just solving it and finally get a solution with 690. So I solve it again, keep the solver solution. So I get 690. Now I realize that all the 40, 40 and 50 are transported. The first person gets exactly 30. Remember, the second person should get anything between 30 and 50. So the person is getting actually 50 here. You see 10 plus 40, 50. So 50 greater than equal to 30, 50 less than equal to 50. The third person should get anything between 40 and 70. Third person is getting 50, 40 plus 10. So the extra 30 that was available, if we meet the minimum requirement, now 20 is given to person number 2 and 10 is given to person number 3. So like this we can solve simple transportation problems using the as a linear programming problem using the solver. Now we move to one more aspect, which is to try and solve the assignment problem. So we go back to the assignment problem here and so we solve the assignment problem. We started our discussion on the assignment problem with a simple example which I am taking here. I am taking a 4 by 4 assignment problem. If you assume that these are jobs and these are people, so each job goes to exactly one person, each person gets exactly one job. What is the minimum cost of assignment? So minimize Cij Xij, subject to Xij equal to 1 summed over j for all I, subject to Xij equal to 1 summed over I for all j. So a 4 by 4 assignment problem will have 16 variables, 16 terms in the objective function, 4 constraints, supply constraints and 4 demand constraints, or if there are 4 jobs and 4 people, 4 constraints, 1 each for the job and 1 each for the person. So each job goes to one person, each person gets one job. So this is the formulation. Now we will show this formulation using the solver and do that. So this is the solution. So there are 4, it is a 4 by 4 assignment problem. So the 16 variables are x11, x12, x14, x41, x12 up to x44. The objective function coefficients are shown here 8, 6, 4, 8, 6, 5, 5, 8 and so on. Now the value for an arbitrary solution is shown here. So 1, 1, 1, 1 and so on. So I am just creating a different solution. So I am just creating a solution like this. So I am creating a solution like this. So this is a feasible solution. Each job goes to one person, each person gets only one job. So you see the row sum is equal to 1 for each of these, the column sum is also equal to 1. So each job goes to one person, each person gets one job. the cost associated with this solution is 33. Now we want to find out the best assignment. So we define these Xij's, and we have, as I said, we have 8 constraints, 4 each for the jobs and 4 each for the people. So and they are all equations because each job goes to exactly one person. So the right hand side values are all 1. So look at this. This is B6 plus C6 plus D6 plus E6, which is here this plus this plus this plus this should be equal to 1, which means if the left side, the rows are jobs and the columns are persons, now the first person gets only one job, second person gets only one job, that is given here. The third person gets one job, the fourth person gets one job, that is the fourth constraint. Each job goes to one person. So look at this constraint, this will be B6 plus B7 plus B8 plus B9. So each job will go to only one person. So like this the 8 constraints are written, all of them are equations with right hand side equal to 1. Now let us go back and try to solve this. So we move to the solver. I have already modeled it in the solver. You can see that the objective function is B10. So objective function is B10, which is shown here. The variables are from B6 to E9. So B6, C6, D6, E6, and this is E9. So the 16 variables are shown here. The feasible solution now has a value 33. Now the assignment problem can also be solved as a linear programming problem, even though the Xij's are binaries, which we have already seen when we studied the assignment problem. We can actually solve it. If we are solving it as a linear programming problem, we can solve it with continuous variables. It will still throw up binary values. That is because of the unimodularity property and so on. So we do not have to explicitly define the Xij's as binaries when we solve the assignment problem. It can be solved as LP. So it is enough to have only these 8 constraints which are shown here. The 8 constraints are here, you can see 4, 5, 6, 7, 8 constraints are here. Now we are ready to solve this problem. So let me go to solve this, and when I solve this you realize that I have a solution with 27. So x13 is 1, x24 is 1, x31 is 1, x42 is 1 with minimum cost equal to 27. So let us go back to the assignment and check what we did here. So when we actually did all the column subtractions and so on, from this we did the row subtractions and column subtractions, and then we solved them. We got a solution with 27. So we are able to get the same solution by solving it as a linear programming problem, which gives us the solution of 27. So small sized assignment problems we can solve using this solver if we have access to this. Otherwise we can always solve it by hand, understand the theory behind it and solve it by hand using the Hungarian algorithm. So both the transportation and assignment we have actually solved them as linear programming problems when we used the solver. Now let us look at one more aspect of the assignment problem. Let us look at this. This is an example of an assignment problem where I have created a problem which has 4 jobs and there are 3 people. So this is not a balanced assignment problem. You see there are 4 rows and 3 columns, there are 4 jobs and 3 people. So if we put a condition that each person gets exactly one job, only 3 jobs can be assigned because only 3 people are there. So 1 out of the 4 is not going to be assigned. So when we did this problem by hand, we introduced a dummy, person, and then we solved a 4 by 4 assignment problem using the dummy. Now when we solve as a linear programming problem, we need not introduce a 4th, we need not introduce a dummy. We will now say that each of these persons will get exactly one job. So there will be 3 constraints which you can see here equal to 1, this is also equal to 1, x12 plus x22 plus x32 plus x42 equal to 1, x13 plus x23 plus x33 plus x43 equal to 1. So each person will get exactly one job. Now each job will go, there are only 3 people, so one of the jobs is not going to be allocated. So we will say that each job will go to a maximum of one person, because one job will not go to anybody. So x11 plus x12 plus x13 is less than or equal to 1, x21 plus 22 plus 23 is less than or equal to 1, and so on. So these 4 constraints for the 4 jobs will be less than or equal to, whereas these 3 will be exactly equations. So that way we do not have to add the dummy and we can solve this. In the earlier, when we had a balanced problem, we had all the constraints as equations, whereas here we realize that 4 of them are inequalities and 3 of them are equations. So let us go back and see how we solve this. So once again I have already set it up. So we realize that these are the 12 variables, x11 to x43, these are the objective function coefficients, these are the values of these variables. So just to show a different solution, I am just looking at 1 here, I have a 0 here, I will have a 0 here, and let me put a 1 here. So I have a solution with 19. Now what happens is, in this solution there are 4 jobs and 3 people. This job is assigned to the first person, this job is assigned to the second person, this job is not assigned to anybody, this job is assigned to the second person, the third person. So out of the 4 jobs, 3 jobs have been given, 1 each to these people, the cost is 19. Once again the constraints are there, 7 constraints. Now the people constraint, each person gets exactly 1, they are equations. The job constraints are inequalities, it goes to a maximum of 1. So let me again set it up on the solver, which I have already done. So the objective function is to minimize the total cost, which is given by B10. So B10 is here. So the objective function will be 8 into 1 plus 6 into 0 plus 4 into 0 and so on. The values of the variables vary from B6 to D9, so which are given here, B6 to D9. There are 7 constraints. The 3 constraints corresponding to the people are equations, which are shown here. They are also shown here as equations. You will see 18 is an equation, 16 is an equation, 17 is an equation. So 16, 17 and 18 are equations. The other 4 are inequalities, which are shown here. So now we are ready to solve it. So just solve the problem. Once again I am not using binary variables explicitly, I am solving it as a linear programming problem. So as long as the problem is within the assignment structure, I can solve it by defining continuous variables and just solve it without defining the binary. Let us see, when we solve this, you realize that we are getting binary solutions here with minimum cost equal to 16. So now you see that out of the 4 jobs, the first job is going to the third person, second job is going to person number 1, the third job is not going to anybody, the fourth job is going to person number 2 with a minimum cost of 16. So this is how we can solve a simple assignment problem using these spreadsheets and solvers. You can go back and check the answer also. The answer happens to be 132142, 4 plus 6. The answer is actually 16. So 6 plus 4, 10 plus 6, 16. This is 3, 2 in this. The rows got changed. So the answer is actually 16 for this problem. So this is how we use the solver to solve and learn simple problems, linear programming, transportation and assignment that can be solved using the solver. So with this we come to the end of this course, that an 8-week course with 5 lessons in each week, and a very quick summary of what we have seen in these 8 weeks. The first week we looked at some problem formulations. We did about 8 different formulations, largely based on continuous variables and linear programming. We did one formulation which was a binary IP, which was the bin packing problem. The second week we introduced simple tools to solve the linear programming problem. We studied the graphical and the algebraic method. Graphical for 2 variables, algebraic also for small sized problems. Third week we introduced the simplex algorithm, which is the most popular algorithm to solve linear programming problems. So we solved maximization problems and minimization problems, explained how the algorithm works for both maximization and minimization. The fourth and fifth week we spent some time on the dual. So in the fourth week we defined the dual, we also learned how to write the dual, and we saw some simple theorems that related the primal and the dual. In the fifth week we looked at some more things about the dual, the economic interpretation of the dual, the meaning of the dual, complementary slackness theorems, how to find the solution of the dual from that of the primal. I went on to say that the simplex actually solves both the primal and the dual, and also looked at matrix method of solving linear programming problems. The sixth week we did transportation problem, we defined the problem and we defined ways to solve it faster and better, even though it can be solved as a linear programming problem. We saw 3 methods to get an initial solution and 2 methods to get the optimum solution, and finally said that a combination of the Vogel's approximation or penalty cost with the UV method is a very nice way to get the optimum solution. The week 7 we looked at the assignment problem, we again defined the problem and we saw the Hungarian algorithm to solve the assignment problem. And the last week we looked at how to solve these problems using an Excel spreadsheet solver, and we gave examples of linear programming, we gave examples in transportation and assignment, and we solved these simple problems using the solver. So with this we come to the end of this online course, an 8-week course on operations research, but with primary emphasis on linear programming and introduction to or fundamentals of operations research involving up to linear programming and simple topics. And we hope that all the students who have registered for this course would benefit from the material that has been presented in the last 8 weeks, and let me wish you all the best at the end of this course. Thank you very much.